Today we're going to be talking about evaluating functions, and we're going to start by defining the term function rule. A function rule defines an output variable in terms of an input variable. For instance, we pronounce this f of x, f with these parentheses and the x inside, equals x minus 3. F of x is really just the same thing as what we would have when we had y equals x minus 3. F is the name of the function. X is the input value. X is what we actually substitute into the function. F of x is the output, which we normally call y. And f with these parentheses and x is read as f of x. So let me show you how this works. Evaluate f of x equals 4x plus 3 when x equals negative 2. So what we're going to do is we're going to put negative 2 in place of x. So you notice what I'm doing here is I'm just putting negative 2 in wherever I see an x in the original function. And now I'm just going to evaluate. 4 times negative 2 gives me negative 8. So f of negative 2 is equal to negative 8 plus 3. So that means that f of negative 2 equals negative 5. So in other words, we're basically saying when we plug negative 2 into this function, we get negative 5 for our answer. Let's go on to the next page. Let's say that we want to evaluate f of x equals 5x minus 6 for f of t plus 3. So we're just going to put t plus 3 in place of x. Now, the thing is, if I put t plus 3 in place of x, I'm going to have to put parentheses around it, because if I've got more than one term I'm substituting, I do need parentheses there. So I've just put t plus 3 in place of the x. Now I'm going to distribute. So I have 5 times t is 5t. 5 times 3 is 15. And then we bring down the minus 6. So combine our like terms. We have 15 minus 6, which gives us 9. So we end up with 5t plus 9. So that is our value of f of t plus 3. Now it says here, find the range of f of x equals 5x minus 3 for the domain of negative 2, 0, and 4. So what that basically means is we're going to plug in negative 2, 0, and 4 into this equation, into this function, and then find out what our output is. So if I plug negative 2 in, I'm going to have 5 times negative 2 minus 3. Well, 5 times negative 2 is negative 10. Negative 10 minus 3 is negative 13. So let's plug in our next value. It says to plug in 0. So f of 0 equals 5 times 0 minus 3. Well, 5 times 0 is 0. Minus 3 is negative 3. Now let's plug in 4. So we have 5 times 4 minus 3. 5 times 4 is 20. 20 minus 3 is 17. So that gives us a range of negative 13, negative 3, and 17. So these would essentially be our y values if we were not using function notation. Okay. So let's move on. Now functions can be combined using addition, subtraction, multiplication, and division. If you have something like f plus g of x, that means you're adding f of x plus g of x. If you have f minus g of x, that means you're subtracting. You're saying f of x minus g of x. F and g are just the names of the function. You can use any variable you want to describe it. F times g of x means you're saying f of x times g of x. And f divided by g of x means that you're taking f of x divided by g of x. So let's take a look at this problem. It says if f of x equals 3x plus 4 and g of x is x, find f plus g of 5. Okay, so let's think about that. Well, if I were going to take f plus g of 5, that would be the same thing as saying f of 5 plus g of 5. Well, that means I'm going to take f of x, which is 3x plus 4, and I'm going to put 5 in for it. So I'm going to have 3 times 5 plus 4, and then I'm going to add to it g of 5, which is just 5. So now let's simplify this. So we've got 3 times 5 is 15. So I've got 15 plus 4 plus 5. Well, 15 plus 4 is 19, and 19 plus 5 is 24. So my answer is 24. Let's try the next one. Let's say we have f minus g of 5. Well, that means I'm going to take f of 5 minus g of 5. Okay, well, so I'm just substituting 5 in place of f of x. So that means I'm going to say f, actually let me erase that. I don't need to write the f down. So that means I'm going to say 3 times 5 plus 4, because that's what f of 5 would be, minus g of 5. Well, if I put 5 in place of x, that's just 5 here. So that, if I write that out, 3 times 5 is 15, so I've got 15 plus 4 minus 5. Well, 15 plus 4 is 19, and 19 minus 5 gives you 14. Let's try this over here. So we've got f times g of 5. So that means I'm going to be taking f of 5 times g of 5. And let's actually write this out in a little more detail. So that means I am going to be saying f of 5, remember, that's like taking 3x plus 4, and g of x is x. And I'm substituting the 5 in. So I'm saying 3 times 5 plus 4 times 5. Okay, because I'm just substituting that in place, the 5 in place of the x. Well, 3 times 5 is 15. 15 plus 4 is 19. So I'm going to be saying 19 times 5. So that will give me 95. And for the last one, we have f divided by g of 5. So that means we're going to be saying f of 5 over g of 5. Now remember, we're just plugging our numbers in. So I'm saying if f of x is 3x plus 4, so I mean you can think of it that way, 3x plus 4. I don't know why this pen is not working. So that means we're saying 3x plus 4 over x, and then just plugging the 5 in place of it. So that means we have 3 times 5 plus 4 over 5. So that means 3 times 5 is 15. 15 plus 4 is 19. So we end up with 19 over 5 for our answer. I know this might seem a little bit tricky, but you'll get used to it in no time as you practice it. On to the next page. Let's say we want to find the inverse of f of x equals 4x minus 2 all divided by 3. Now, just like we did before when we learned about inverses, we want to rewrite the equation using y and then switch the x and y variables. So we're going to start by just saying y equals 4x minus 2 over 3. So that's the first part. Second part, we switch the x and the y variables. And then in the third part, we solve the equation for y. Well, to start off with, I'm just going to rewrite it here. So x equals 4y minus 2 over 3. We want to get rid of this denominator of 3 first of all. So we're going to have to multiply each side by 3. So the 3's on the right will cancel. So I have 3x equals 4y minus 2. Again, we're still solving for y. So we want to add 2 to each side. Keep in mind these are not like terms, so I have 3x plus 2 equals 4y because the 2's on the right canceled. And now I want to divide everything by each side by 4. So I end up with y equals 3x plus 2 over 4. Now keeping in mind that this is the inverse of our function, the symbol, I'm going to go back up here, the symbol that we use for the inverse is listed here at the top. It's what I've just circled, f to the negative 1 of x, which means the inverse of the function of x. So all we're going to do in our last step is replace the y with f inverse of x. So f inverse of x equals 3x plus 2 over 4. So let's go on to the next page. You're given this problem if f of x equals 2x minus 3 for the domain negative 2, negative 1, 0, 1, 2 is the inverse of function. Okay, now remember, you can only have a function if its graph passes the vertical line test. So that's what we're going to kind of be looking at here, but we're going to do this step by step. First of all, we want to evaluate the function for each of the given domain values. So we're going to start by saying f of negative 2. We're going to plug our numbers in. I'm going to change colors here. So we're going to have 2 times negative 2 minus 3. And 2 times negative 2 is negative 4. Negative 4 minus 3 is negative 7. Okay. F of negative 1 means you're saying 2 times negative 1 minus 3. Well, 2 times negative 1 is negative 2. Negative 2 minus 3 is negative 5. F of 0 means you're saying 2 times 0 minus 3, which is just negative 3. F of 1 means that you're saying 2 times 1 minus 3. 2 times 1 is 2, and 2 minus 3 is negative 1. And lastly, we have f of 2 So we're saying 2 times 2 minus 3. Well, 2 times 2 is 4. 4 minus 3 is positive 1. Now we want to write the ordered pairs. So remember, we started off by plugging in negative 2, and we got negative 7 for our answer. The next one, we plugged in negative 1 right here. We got negative 5 for our answer. Next, we plugged in 0 and got negative 3 for our answer. Next, we plugged in 1 and got negative 1 for our answer. And lastly, we plugged in 2 and got positive 1 for our answer. So now, we wanted to know if the inverse was a function, so we're going to find the inverse of these points, which just means we're going to switch them. So instead of negative 2, negative 7, we're going to have negative 7, negative 2. Instead of negative 1, negative 5, we're going to have negative 5, negative 1. Instead of 0, negative 3, we're going to have negative 3, 0. Instead of 1, negative 1, we have negative 1, positive 1. And instead of 2, comma 1, we're going to have 1, comma 2. So now what we're going to do is graph those points. So we've got this graph here. So we have negative 7, so it means we go to the left 7 and down 2 for negative 7, negative 2. Negative 5, negative 1, we go to the left 5 and down 1. For negative 3, 0, we go to the left 3 and up 0. Negative 1, 1, we go to the left 1 and up 1. And 1, 2, we go to the right 1 and up 2. And imagine if we were to pass a vertical line through these points, at any given time, that vertical line would only hit one point. It would never hit more than one. So yes, it does pass the vertical line test, and if it passes the vertical line test, it is indeed a function. So we'll say the inverse is a function. So that is it. Thank you for joining me.